Bismillahirrahmanirrahim. Hello everyone. In this video, we are going to discuss 3D equilibrium force systems. As the name suggests, 3D equilibrium force systems means those systems which are in 3D, and 3D means space. Okay, they are also being termed as non-coplanar force systems. Okay, there are two kind of systems: coplanar force systems and non-coplanar force system. Coplanar force system, as the name suggests, coplanar, which lies in a single plane, are basically 2D systems. Okay, like this example, if you look at this plane YZ, all these forces are lying in a single plane, which is the YZ plane. So this is a coplanar force system. Okay, but if the forces lies in a three-dimensional space, which is termed as non-coplanar, whose example you can see in this cube. You can see this is x-axis, z-axis and y-axis. One force is lying in the yz plane. This force is lying in the xy plane. And if you look at it, another force, this force is lying in the xy plane. Okay, so xy plane, if you look at it over here, this is xz plane. This is xz plane. This force is lying in the xz plane. This force is lying in the xy plane, and if you look at it, this force is lying in the yz plane. So these forces, if you look at it, they are all lying in space. So this forms a non-coplanar force system. So non-coplanar force systems are of various categories. Okay, they are concurrent force system, the parallel force system, non-concurrent, non-parallel force system, and a general force systems. These are all basically studied under the category of non-coplanar force system. So if you want to define it very precisely, it says if all the forces in a system do not lie in a single plane, they constitute the system of forces in space, which is also termed as non-coplanar. Okay, it has many different examples. So if you look at it, here we have basically got uh, non-coplanar force systems. These are all 1, 2, 3, 4. These are all non-coplanar force systems subtypes. Okay, these are its generic bodies, free body diagram, and we can also write their independent equations, which is very helpful in statics problems and mechanics problems. If you know to write an independent equation of a non-coplanar force system, so this is very useful. Okay, so if you have a force system which is says a non-coplanar force system which is concurrent at a point. Okay, so if you look at it, this is a generic non-coplanar force system on which all these forces F1, F2, if you look at it, F4, okay, F4, F5, all these different forces are basically converging at one point, which is O. Okay, then these types of force system will become termed as a non-coplanar force system which is concurrent at a point. Okay, now since all these forces are converging at a point, so we can say that there will be no movement in this body. Okay, so the equations that we can write, the independent equations which are not dependent on any of their types, is sigma fx equals to 0, sigma fy equal to 0, and sigma fz equal to 0. Okay, so this is one example. If you look at it, this picture, this cube, okay, all these forces, if you look at it, all these forces, whether you say this force which is F5, F3, F4, F1, they are all basically concurrent at this point. Okay, at this specific point, they are all concurrent. You can see in the cube. Or if you look at it, an example of all these a tripod example in which these different legs are basically in space and they are all converging at this unique point. Okay, so this is another example of a non-coplanar force system which is concurrent at a point. Okay, so if you look, we go to another force system here. Okay, so another force system is called as again a non-coplanar force system which is concurrent at a concurrent with a line. Okay, so non-coplanar force system concurrent with a line. Okay, so if you look at it here very precisely, you will see that in this system we have basically a line which is parallel to the x-axis, and we have different forces which are basically lying along the basically different orientations in space. Okay, so we can say that if we resolve these forces into its components, which are basically along the y-axis and along the z-axis, if you resolve it, so basically we can very easily write it as the independent equation sigma fx equals to 0, sigma fy equal to 0, sigma fz equal to 0. But since all these forces, space forces in 3D, have the capability of rotating this body about the y-axis and z-axis, so we can always write the independent equation for moments as sigma my equal to 0 and sigma mz equal to 0. Okay, you cannot write sigma mx because they are all basically these forces are concurrent with a line which is parallel to the x-axis. So you cannot write sigma mx equal to 0 over here. You can always write, because these force components have the tendency to rotate the body about the y-axis and the z-axis. Okay, so let's go to and I have also given you a very good example over here also. If you see that these forces are lying in different planes, but they are all basically concurrent with this line. If you can see, they are all concurrent with this line. This example will help you further. So let's go to another example. We again say that our system is non-coplanar force system which is parallel. Okay, you can say non-coplanar parallel force system. Okay, so again if you look at it, this generic body, or you have seen many forces here. F1 you can see, you can say F4, you can say F2, F3, F5, all these forces. But there is one unique thing about these forces, is that these forces are all parallel to the x-axis. So we can basically sum them along the x-axis. So for the independent equation, we will write sigma fx equal to 0. But since these forces are all parallel to the x-axis, so they have the tendency to rotate this generic shaped body about the y-axis and the z-axis. To further enhance your knowledge, you can see this example. Okay, the main thing is x, y and z. So this is another example of a non-coplanar parallel force system in which all these forces are parallel to the y-axis. Another example over here also, if you see, this is your x-axis, y-axis and z-axis. This is a cube, and you can see all these forces are parallel to the z-axis. Let's go and study another category here, which is basically termed as a non-coplanar force system, which is general in nature. Okay, when you say general, so you can see there are different forces acting in space, which means some in line xy, some in line xz, some in line yz planes. So, and since it is general, so they have also shown you here a couple moment over here also, which is a free vector. They have shown you here. So because it is generic in nature, so the independent equations could be written as sigma fx equal to 0, sigma fy equal to 0, sigma fz equal to 0, sigma mx equal to 0, sigma my equal to 0, sigma mz equal to 0. And if you further want to see any practical example of this is an example of if you look at it, this is an example of a general force system in which different forces are lying in different planes, and there is also a couple moment over here. Okay. Now we go to another example. We see a non-coplanar force system, but this system is non-concurrent in nature. Okay, non-coplanar. So you can say it's a non-coplanar, non-concurrent. So it's a non-coplanar. You can say it is a non-coplanar, non-concurrent force system. Very typical type over here, shown you over here. So again, if you look at it, this basically it's some generic body whose origin is O over here. So all these bodies, if you forces, if you look, they are all lying in space, because you can say xy plane, yz plane, xz plane, different bodies, forces lying in different planes. Okay, so this is an example of a non-coplanar, non-concurrent force system. And if you look at it, its equation will be sigma fx equal to 0, sigma fy is equal to 0, sigma fz equal to 0, sigma mx equal to 0, sigma my equal to 0, sigma mz equal to 0. These are the independent equations that you can use to solve this kind of a system, non-concurrent force system, okay, which is non-coplanar. So if you want to look, you can have an example over here also being shown to you. If you look at this example, here you can see that you have basically got a van over here, okay. If you look at it, so there is one force which is called the driving force acting, okay. Then there are horizontal forces over here acting. There is air resistance, there is weight, there is normal reaction force, and then these orange are the frictional force. So these all these forces are acting in different planes of this van, okay. So we can say this is an example of a non-coplanar, non-concurrent force system, okay. So with this I hope you have understood uh, what are non-coplanar force systems, what are non-coplanar force systems, and what are its subtypes that I have fully explained to you with examples. I thank you all, and I request you all to subscribe to my channel so that you can see all these challenging theoretical topics of statics which are being fully explained by me. Thanks a lot and have a good day.